Hello everyone. You are on the SuperKit channel. In the discussion of almost any power station, potential buyers are interested in whether this power station works as an uninterruptible power supply. Reading the manuals of my power stations, I found information in the description that they work as a UPS. But can they replace the long-existing type of computer components in the form of UPS units? A UPS was created to combat voltage surges, as well as, in case of a complete disappearance of electricity, to have the ability to correctly shut down the computer, at least in order not to lose data while working with some documents. Usually it has 1 or 2 batteries of 12 volts. The capacity of one battery is 7 or 9 amp hours. There is a built-in relay-type voltage stabilizer, which, in the event of the voltage going out of the declared range, allows returning acceptable voltage for the connected device. The UPS itself has its own operating voltage range, which is noticeably wider than the potential deviations from the norm for most devices. Using my such device as an example, this range is from 145 to 290 volts. At the same time, at the output it gives a range from 200 to 255 volts. The switching time is from 2 to 6 milliseconds. And if the voltage available in the network does not fall into the interval from 145 to 290 volts, then it will simply switch the device connected to it to battery operation, while itself will stop powering itself from the network, and will work until the battery is completely discharged. As a rule, it has a modified sine wave, which significantly reduces the cost of the product. However, this is not an obstacle for computer operation. In the case when we are talking about a classic UPS for a PC, and also about a UPS with an external acid battery, then it should be understood that such a UPS is definitely not about fast charging. At least because acid batteries cannot be charged with a current that is higher than 10% of the capacity. Usually, the full charging time is about 6 hours, since the battery is not discharged to zero in order to protect it from degradation. This depends on the model. A power station is a device of a slightly different meaning. First of all, it implied delivering electricity to where it could not possibly appear, for example, some forest, where the power station was taken along to connect some electrical devices. Or simply to accumulate electricity in case of its unstable supply. Again, using my power stations as an example, for their operation the voltage in the network must be in the range from 200 to 240 volts, which is clearly noticeably narrower than the one previously voiced for the UPS. The switching time is from 10 to 20 milliseconds, and if the electricity disappears, then such a station will work like a classic UPS. But if the electricity does not disappear, but simply goes beyond the operating range, then at best the station will simply show an error. Perhaps it will not even stop its operation at the same time, but it will switch to battery operation. But definitely, the power station will not return the voltage to the operating range, because it does not have such a possibility. So the fact that a UPS operating mode is for the power station does not mean that it will be able to correct the voltage deviation, and it will not be able to return it to the acceptable range for the operation of the connected device. And in general, unlike a UPS, which makes, for example, high voltage lower and vice versa by changing the number of working turns on the coil by means of a relay, the power station itself, like the same computer that is connected through the UPS, can fail, especially when exceeding the voltage operating range established. A power station, in any case most power stations, itself needs a standard normal voltage range. As a rule, it has a pure sine wave for a wide range of connected devices. Modern power stations for the most part have the option of relatively fast charging from 1 to 2 hours, since, for the most part, they are built on modern LiFePO4 batteries. Yes, there are some exceptions. For example, with the same sine wave, there are power stations with a modified sine wave and low battery capacity, and vice versa. There are UPS units with high battery capacity, most likely it will be an external battery, and with a pure sine wave. There are even UPS units with a built-in LiFePO4 battery, as in my case. Videos are circulating on YouTube where acid batteries in a UPS are replaced with Li-ion. This significantly adds capacity, but, as a rule, even reduces the final output power, and also, without additional intervention into the UPS circuitry, will not make it possible to use the Li-ion battery capacity to the fullest, since the UPS threshold shutdowns for acid batteries occur at a higher voltage than for Li-ion. This means that there will still be capacity in the Li-ion batteries, but there will no longer be an opportunity to use it. For those who cannot or do not want to assemble such a battery themselves, there are lithium batteries of standard size for replacing the stock acid ones. But a purchased battery, just like a homemade one, will not solve the issue with incomplete discharge of such a battery. Therefore I would not do so. And the economic issue is also relevant here. I simply immediately bought a UPS with LiFePO4 for batteries. Since there the use of the full capacity volume is already calculated from the factory, while for acid batteries a system discharge below 30% will lead to rapid degradation in capacity. Therefore, if you want to use a UPS on an acid battery, then keep in mind that it will very quickly lose its capacity during constant strong battery discharges, if, of course, the UPS will allow such deep discharges. At the same time, a UPS with an acid battery, which was almost never discharged until complete shutdown, has almost not lost its capacity over a period of a little more than a year from the moment of purchase. However, those very shutdown thresholds to preserve the lifespan of the acid battery lead to the fact that a UPS on an acid battery with a capacity of 96 Wh powers connected devices for less time than a UPS with a LiFePO4 battery and a capacity of 77 Wh. If anyone remembers, my mini computer from eBay together with a 24-inch monitor from a UPS with an acid battery of the designated capacity works for 51 minutes, while from a UPS with a LiFePO4 battery of noticeably lower capacity, the operating time was 1 hour 18 minutes. This despite the fact that the UPS with the LiFePO4 battery is even older, and at the time of the test it was 1.5 years old, while the UPS with the AGM battery was only 1 year old. Agree. The advantage of a UPS on LiFePO4 is obvious. This despite the fact that the AGM battery also weighs about 2 to 2.5 times more, and because it is larger in size than cylindrical LiFePO4, the UPS itself also has larger dimensions. However, although my UPS with LiFePO4 costs more, with the installed cost-reduced circuitry it charges for about 4 hours, which for such a low capacity is very long. Despite the fact that my exact UPS model on the internet is, to put it mildly, not rated very highly, and especially its variant with a capacity of 153.6 Wh, I have been using my UPS for almost 2 years already. During this time I have not noticed any loss of battery capacity, and in general there are no problems at all, everything works. Although, I regularly discharged and charged it first as a portable power source for lighting, and later for system use with a router. If anyone is interested, then with total consumption together with the modem for fiber optics, my router consumes 7 watts. With such consumption the Mars Riva UPS with a battery capacity of 77 Wh lasted for 0.5 hours. Obviously, most of the energy was consumed by the inverter, therefore I stopped such use. Lately my main computer while operating from the network is powered exactly through it. One can, of course, bring out a 5521 connector directly from the batteries and exclude inverter operation, but that is already a completely different story and I do not need that. I will add that it is visible that this UPS was designed by someone who thinks about the emotional component of the user. There is no fan and noise from it here, and the sound notification about switching to battery operation is also thought out. It beeps a couple of times quickly and unobtrusively and that is all, then silence. That is, the user is informed about switching to battery operation, and the UPS does not annoy the person with a system sound signal. At the same time, there is no need to press any button so that the UPS no longer beeps. And only when very little charge remains, then the beeper already turns on, which depending on the load informs from 10 seconds to 1 minute, after which the UPS completely shuts down. They write that it does not handle the declared load. Probably such a thing can happen, but my undemanding computer consumes less than 100 W together with the monitor, and even 100 W do not lead to the instant shutdown of such a UPS. There should be reasonable solutions for everything. Your money, your right to use your power station however you want, but I am not ready to torture a device costing several tens of thousands of hryvnias as a constant cushion because of a possible power outage. Especially since the power station itself needs protection from voltage fluctuations. For this I have a much cheaper UPS, and although this is not very convenient, in this situation it is better to correctly shut down the work, and then reconnect to the power station. Links to useful things are in the description. Rate the video. Subscribe to the channel, there will definitely be more videos about different devices. If there are questions, you can ask them in the comments, I will try to answer them. Thank you all and see you again.